Good morning again. Thursday, 19th of March, 2020, year of COVID-19. I'm going to do a couple examples from worksheet 5. It's percent, comp, and density problems. We've done similar problems earlier in the year, but it bears some review. So I'm going to go over a couple of the examples, and then I'm going to assign this one for homework, post a key, and we'll take it from there. All right, so here we go. If we look, we'll do a couple simple ones first. Let's do number 1. All right, so you've got your worksheet 5 out. I've got 34.0 grams of sodium chloride and 100 grams of water. Well, once again, water is a part. It's not the whole. It's the solvent. So you've got 34.0 grams of NaCl, and you've got 100 grams of H2O. So you have 134 grams of solution. That's the whole. So your percent NaCl, another dead marker, is 34 grams of NaCl out of 134 grams of solution times 100, 3 sig figs, and survey tells me, I've got the key somewhere, 25.4%. Percent NaCl by mass. Okay, so that's number 1. Pretty straightforward. We look at number 2. They have 20 grams of barium hydroxide and 380 grams of solution. Solution is the whole. So in number 2, you say, all right, you want to know your percent barium hydroxide. If you didn't remember the nomenclature there's a little note on the key about that. You've got 20.0 grams of the barium hydroxide out of 380 grams of solution. Part over whole, take that whole thing times 100. And that turns out to be about 5.26% barium hydroxide by mass. Pretty straightforward, easy peasy. All right, so some of these problems, though, they're a little more deceptive than that. It's a repeating theme in these worksheets. Remember that the density of water is 1 gram per mil, which also means it's 1 kilogram per liter. One thing about marker, no erasing. So that, a lot of times these worksheets are going to say, you know, you've got milliliters of water. Well, that's the same thing as grams of water. If you look at number 4, for example, they said 970 milliliters of water. Well, that's 970 grams of water. Let's get into a more complex example. All right, my key, I showed you how to do this dimensionally and when simple enough algebraically. Once again, I don't care how your brain's wired. Let's look at number 7. Number 7 says, I think this is from a worksheet we've done directly earlier this year. Number 7 says you've got a solution of ethanol and water. They give you the density and they give you the percent by mass. Ringing a bell? So whenever you've got problems like this, they said the density of the solution was 0.949 grams per mil. Well, it is really smart to add solution to your numerator and your denominator. Do that. It's going to help you when you go through the dimensional analysis. They also said 34.0% by mass ethanol. I'll just abbreviate that ETH, which means 34 out of 100, 66 out of 100, 34 to 66, part over whole, other part out of whole, part to other part. So this is the ethanol, this is the solution, this is water, this is solution, this is ethanol, this is water, and this is a unit of mass, the same unit of mass there, same deal here, same deal here, same deal here, same deal here. Whatever those units are, if it's grams over grams, or kilograms over kilograms, or milligrams over milligrams, as long as there's some kind of gram in there and they match numerator and denominator, you're good to go. So we've got this information available for use. So let's look at the first problem. It says, quite the color scheme going on here today. What is the mass of 8 liters of solution? 8.00 liters of solution. Now, liters here, milliliters here. We talked about this earlier in the year as well. You may recall, I'll do this separately. If I've got 0.949 grams per milliliter, and there are 1,000 milliliters in a liter, and there are 1,000 grams in a kilogram, well, the mils are gone, the liters stay, the grams are gone, the thousands are gone. I get 0.949 kilograms per liter. So a gram per milliliter is the same thing as a kilogram per liter. That can save you a couple steps in your dimensional analysis. So 8.00 liters of solution, if I take and rewrite my density as kilograms per liter, I could say, well, I've got 0.949 kilograms of solution per liter of solution, and I am left with kilograms of solution, which is a mass, which turns out to be 7592. I want 3 sig figs, 7.9. 3 sig, if I'm working in kilograms here, 7.59 kilograms of solution. And if you went to grams, it's 7,590. They didn't specify, they said mass. Well, kilograms are mass. Let's look at B. B says, what's the mass of water in 8 liters of solution? Okay. Keeping in mind, I've got my density and my 3 expressions of percent to work with. So I'm start with the simple 8 liters of solution. Well, liters of solution in the bottom, that's got to go there, right? So I'll say, all right, back to my density, 0.949 kilograms of solution for every 1 liter of solution. Put kilograms of solution in the bottom. I'm looking for water, so I'll put kilograms of water up top here. Water over solution, 66 over 100. That's going to give me the mass of water. And you can take it to grams or kilograms. I'm working in kilograms this morning. 8 times 0.949 times 66 divided by 100. And you've got roughly, you want 3 sig figs, 5.01 kilograms of water. All right, so worksheet 5 has some problems like that. It's not tremendously new stuff, but it is a good idea to practice. We won't focus on too much more new stuff today. I want you to finish worksheet 5. I will post the key tomorrow morning, and then we'll move into parts per million, and then we'll move into colligative properties, which is a little bit of algebra. Finish up with table F again, that's review, and we'll get into our Regents review and then the practice test. Hang in there. We'll get there. Talk to you soon.